Okay, algebra students, we've got 5.4 notes for solving systems of equations using substitution. Now I'm going to be straight up with you. This lesson is going to be challenging. You got to take your time. You got to think about what I'm saying and what you're writing down. Stop, pause, think about it, try it yourself, go back and watch it again if you need to. Because you're going to use everything you've learned in algebra, all working together on this lesson. So, got to be on your A game here. Okay? So, first of all, a few reminders. A system of equations has one solution when the graphs of the lines intersect. And that means when they intersect, we know they have different slopes. The slopes of the lines are different. That means when you graph them, they're going to intersect and you're going to find one point that works for both of them. A system of equations has no solution when the graphs of the lines are parallel. So parallel lines have the same slope. They have the same slope, and when you graph them, they look like this. They never intersect. That's why there's no solutions. And a system of equations has infinitely many solutions when the graphs of the lines are the same, or when they graph on top of each other. The same line. It has the same slope, and they have the same y-intercept. And so when you graph those, if you graph one, there it is. You graph the second one, it goes right on top of the other one. It's exactly the same. Okay? Now, we already learned how to do this using graphing. Graph, and we did second trace 5, enter, enter, enter. Now we're going to learn a new way called using substitution. Now, the reason we use substitution is so that we can make one of these variables go away. Remember, systems of equations have at least two variables. But except for graphing, when we put them in our calculator and it finds it for us, if we're going to solve systems of equations just by calculating, you can only have one variable. If you have two, you'll never get it solved. You're always going to have the y and the x there at the same time. Like when we change it into our equations into y equals. You know, you have a y on one side, you have an x on the other side. You can't get it solved. So we have to make one of the variables disappear. And this is how we're going to do it. We're going to use substitution. And I'll show you what I mean. So let's look at number 1. In this first equation, it says x equals 7. That's the first equation. The second equation says 2y plus x equals 3. Now I want you to think about this. If this equation says that x equals 7, how about we take that 7 and substitute it for the x in the other equation, and we can solve it. So look, we're going to say 2y plus 7. I always like to substitute using parentheses, because if you have a negative, it could make a difference for you. 2y plus 7 equals 3. So you don't have anything to distribute, nothing. What we're going to do is just subtract 7 from both sides, and we get 2y equals negative 4. Now we divide by 2, and we find out that y equals negative 2. So the solution to this system of equations is x is equal to 7 and y is equal to 2. Negative 2, excuse me. Negative 2. Now, how can we make sure we did it right? Well, let's take our solution and plug it in. Well, in the first one, since it only has one variable, we plug in 7 and 7 equals 7. True. Okay, let's try in the second one. If y is equal to negative 2, we'll take this 2 here, leave it as it is, and we're going to substitute negative 2 plus x is 7 equals 3. So this is negative 4 2 times negative 2 is negative 4, plus 7 equals 3. So, is this true? Negative 4 plus 7, guess what? That equals 3. It's true, so it works. Okay, now that one was pretty easy. Let's go to one that's a little harder. Okay, on the second one, we're told that y is equal to x plus 1 in the first equation, and the second equation is 2x minus 4y equals 12. Okay, well, on this first equation, we know that y is equal to x plus 1. So I'm going to take that x plus 1 and I'm going to substitute it for this y right here in the second equation, because this says y is equal to x plus 1. So we're going to put the x plus 1 in there for y, because that's what it equals. Okay, so let's try it. So we have 2x minus 4, and I'm going to use a different color here. We want to substitute x plus 1. Remember, I said always substitute using parentheses, is equal to 12. So you can see I took this x plus 1, and instead of y, we put it in there because y equals x plus 1. Now we're going to solve it. We have 2x, nothing happened there. Now we're going to take negative 4 times x, and you get minus 4x. Then you're going to take negative 4 times 1, you get minus 4, equals 12. So we can combine like terms right here. We get minus 2x. Then I'm going to add 4 to both sides. And I'm going to move my answer up here. We get negative 2x. These cancel out, equals 16. And then I'm going to divide each side by negative 2. So I get x equals negative 8. So that's the first part of our solution. Remember, a solution is always x, comma, y. We always want an x and a y. Well, we got the x. Now we need to figure out the y. And the way we figure out the y is to go back to the original equation. And since we know that x equals negative 8, you can take that negative 8 and either put it in for this x here or for this x here. It doesn't matter which equation you use. You'll get the same answer for both equations. So let's use it in this one. That's the easier one. So we're going to take y equals, and instead of x, we're going to substitute negative 8 plus 1. Well, what is negative 8 plus 1? Negative 8 plus 1 is equal to negative 7. So there's our answer. Y equals negative 7. So if I was going to write this solution as an ordered pair, I would do it like this. X is negative 8, comma, y is equal to negative 7. So negative 8, negative 7 is our solution. You want to make sure it works. Plug those things in for x and y in your equations and make sure your equations come out true. Okay, let's look at number 3. We have y equals 2x minus 10 and y equals 5x plus 5. So what we want to do is substitute. You can either take this 2x minus 10 and substitute it for this y, or you can take this 5x plus 5 and substitute it for this y. So it doesn't really matter. I'm going to take this top one and substitute it for that y right there. So since y equals 2x minus 10, I'm going to put 2x minus 10 substituted for the y equals 5x plus 5. And so now we only have one variable, and now we can solve. Okay, so we're going to subtract 2x from both sides. And I'm left with negative 10 over here is equal to 3x plus 5. Now I'm going to subtract 5 from both sides. Remember, when the signs are the same, add them up and keep the sign. Negative 15 equals 3x. Divide by 3, and x equals negative 5. Now, once we know that x equals negative 5, once you have one of the answers, you can go back up to your original equation and take this negative 5 and substitute it in for one of the x's, and it doesn't matter which equation you use. It just doesn't matter. So I'm going to use the first one. So we have y equals 2, and I'm going to substitute the negative 5 in there, minus 10. So 2 times negative 5 is negative 10. So I have negative 10 minus 10. The signs are the same. What do we do when the signs are the same? We add them up and keep the sign. So we get y equals negative 20. And there's the other half. So let's write our answer as a coordinate pair is negative 5, comma, negative 20. X is negative 5, y is negative 20. That's the solution that if we were to plug into these two equations right here, it would make them both work out at the same time. Okay, let's go on to number 4. We have x plus y equals 6 and 3y equals negative 2x plus 2. Now, what we want to do is get one of these equations to either say x equals something or y equals something, because once we do that, then we can substitute. So what I think I'm going to do is take this first equation, x plus y equals 6, and I'm going to subtract x from both sides. So I get y equals negative, well, we could just do it like this. 6 minus x. It's fine with me. So y is equal to 6 minus x. Well, now that I know what y equals, I'm going to take that, 6 minus x, and I'm going to substitute it for the y in this equation. So we have 3. We bring this 3 down, and instead of y, we're going to put 6 minus x is equal to negative 2x plus 2. So I just wrote this equation, except I substituted for the y. Now let's distribute. You get 18 minus 3x is equal to negative 2x plus 2. Now there's several ways you could work this problem, but I'm going to add 3x to both sides. Boom, 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 like that. These cancel out, so we have 18 equals x plus 2. Subtract 2 from both sides, and you get 16 is equal to x. So there's one of our answers. 16 equals x. Now let's try and get the other side of the answer, and we're going to take that 16 and we're going to plug it in to one of the original equations. So let's go back up here. I'm going to erase our work right there. And so I can either take this equation or this one and use it. So let's use the top equation because it looks like it's the easiest. Okay? So we have x plus y equals 6, and we know that x is 16. So we're going to have 16 plus y equals 6. So let's subtract 16 from both sides, and I get y equals negative 10. And so our solution to this system of equations is 16 comma negative 10. Here's your x, here's your y. If you plug those back into both of these equations, they'll both come out true. Okay? Hey, let's try number 5. We have y equals 3x minus 7 and 3x equals y plus 7. So on this first equation, it tells us what y equals. Y equals 3x minus 7. So we're going to take this and we're going to put it in for this y right here. Okay? So let's write our second equation. 3x is equal to, and instead of y, we're going to substitute 3x minus 7 plus 7. Okay, so there's nothing to distribute here. I can just go ahead and take the parentheses off now. I always like to substitute with parentheses because every once in a while you're going to have something related to the negative sign or something that's going to make a difference in it. Okay, so we have 3x equals 3x minus 7 plus 7. Well, minus 7 plus 7, they cancel each other out. And now we have 3x equals 3x. And this is something that I'm not sure we've covered before in this class, but when you get to this point, if you have two sides of the equation that look exactly the same, 3x equals just 3x, that means we have infinite solutions. It doesn't matter what we put in for x, it'll work out the same on both of these equations. So on these two equations, everything, any number you pick will work. It's infinite number of solutions. And it's always going to be that way if you're solving your equation and you get down and both sides look exactly the same. So let's try number 6. Okay, now let's try number 6. Again, we're told in this first one that y is equal to negative x plus 3. So we're going to take that and put it in for that y right there. So we're going to say 2, then we're going to substitute negative x plus 3 plus 2x equals 4. Now let's go ahead and distribute. We get negative 2x. 2 times negative x is negative 2x. And 2 times 3 is 6 plus 2x equals 4. Okay, now I want you to notice, here's my equal sign. I have minus 2x and I have plus 2x on the same side, and they cancel each other out. So what are we left with on this equation? We have 6 is equal to 4. Now I ask you, is the number 6 ever going to be equal to the number 4? No, that just is not going to ever happen. It's impossible. So if you ever get to this situation, remember over here we had two things that looked exactly the same, infinite solutions. On this one, when we have something that's totally untrue, a false statement, that means there's no solutions. There's nothing that we can put in for x that's ever going to make both of those equations work at the same time. Nothing. No solutions. So if you get this point, you're done. No solutions. Okay, well, let's try number 7. Okay, so look at your first equation. And you know what? I think you could probably do this one without me. You've done enough tries. We see that y is equal to 2x minus 5. What are you going to do with that 2x minus 5? You're going to substitute it for y in this other equation. Now remember, use parentheses because this one's very important. So we bring our 4x down, minus, and what are we going to put in there? 2x minus 5 equals 7. Now this is why the parentheses are really important. Because we have this minus sign in front of the parentheses, we need to distribute it. It's like saying that there's a minus 1 right here. You can't see the number 1 there, but it's there. And we've got to distribute that minus through the parentheses. So the 4x doesn't change. But now we have negative 1 times 2x is negative 2x. Negative 1 times negative 5 is positive 5. You see, because when you have a negative sign in front of parentheses, when you distribute a negative sign through, the signs change. This 2x became minus 2x, and this minus 5 became plus 5. So that's what happens. The signs change. Equals 7. Okay, so now, what's 4x minus 2x? We can combine like terms. That's 2x. Now, let's subtract 5 from both sides. So we get 2x equals 2. Divide by 2. And you get x equals 1. Okay, now that we know that x equals 1, let's go back to our original equations. And you can plug that in to get the y. So I'm going to use this top equation. So y equals 2, and instead of x, we're going to put this 1 right here. 2 times 1 minus 5. So we get y equals 2 minus 5. And what is 2 minus 5? Y equals negative 3. And so our solution we want to write as a coordinate pair 1, comma, negative 3. X is 1, y is negative 3. And if you were to put those into both these equations, they would both come out true. Okay, now we're going to take, using substitution, and do a real life problem. So it says the length of a rectangle is 5 more than the width. The perimeter of the rectangle is 22 feet. Find the length and the width. So the first thing we're going to do is write let statements. We did this, we've been doing this as we've been doing systems, so we're going to let, how about we let L equal the length and W equal the width. So the first equation that they ask us to write is the relationship between the length and the width. So look, that's the first part of this. The length of the rectangle is 5 more than the width. So let's write that. The length is, that means L equals. So L equals 5 more than the width. So that's W plus 5. There's the equation for the relationship. Now, the second equation it asks us to write is the one related to the perimeter. So we know that the perimeter is 22 feet. And remember, on a rectangle we have a length, we have a length, we have a width, we have a width. So if we're going to do an equation for the perimeter, we add them all up, right? So I need the 2 lengths plus the 2 widths. So we're going to say 2L plus 2W equals the perimeter, and it tells us the perimeter is 22. Okay, now let's use substitution. Well, it actually says to use our calculator to solve the system. We could use our calculator or we could do substitution. I don't think it really matters. But I'm going to do it both ways. How about? First of all, since this one says L equals, we want the second one to be L equals if we're going to use our calculator. So we're going to subtract 2W. So we get 2L equals negative 2W plus 22. Then divide by 2. And you get L equals, and negative 2 divided by positive 2 is negative 1. So we get negative 1W, which I'm just going to write as negative W plus 11. Now, you can put this in your calculator, but instead of using L and W, you're going to use Y and X. So if you went to Y equals, you do Y1 and Y2. Then you're going to hit graph. Then you're going to do second, trace, 5, and then enter, enter, enter. Now that's how you do it with the calculator. But what would happen if we just use substitution for this problem? Because we can. It tells us here that L is equal to W plus 5. So if L is equal to W plus 5, I can take this 2L right here and say 2 times W plus 5 plus 2W equals 22. So I'm going to distribute. I get 2W plus 10 plus 2W equals 22. So I'm going to add 2W plus 2W. I have 4W on this side. Subtract 10. 4W equals 12. Divide by 4, and W equals 3. And so now, since I know that W equals 3, I'm going to put that in that equation right there. And so we're going to say L is equal to 3 plus 5. So L equals 8. which is the same thing you got when you did it on your calculator. You got 3 and you got 5. So 3 equals the L, so the length is 3 feet and the width is, oh, excuse me, I did it backwards. The width is 3 feet and the length is 8 feet. Booyah! Okay, one more and we're done. A beginner's artist kit costs $6.35 and contains 2 brushes and 5 jars of paint. The standard kit has 4 brushes and 12 jars of paint for $13.20. Okay, so assuming all the brushes cost the same and all the jars of paint cost the same, write a system of equations. So let's start by defining our variables. Let's say we let B equal brushes, and let's say J equals jars of paint. And you know what? Just for grins, next to it, let's say that this would be the Y and this would be the X. Okay? Now we're going to do 2 equations. We're going to do one for the beginner's art paint. And so we have 2 brushes, so that's 2B plus 5 jars of paint, 5J, is equal to 635. And then the second one, the standard, we call that STD, is 4 brushes plus 12 jars of paint is equal to $13.20. Now it says put these things in our calculator to find the answers. Well, to do it in our calculator, we're going to have to solve them so that they say Y equals. So in this case, we're going to get them so they say B equals. Okay? We want to get B equals. So on the first one, we have 2B plus 5J equals 635. Let's subtract 5J. So you get 2B equals negative 5J plus 635. We divide everything by 2. And you get a really nasty looking equation. You get B equals negative 2.5J plus 3.175. You're going to have to put the whole thing in there like that. Now let's solve the other one. We have 4B plus 12J equals 1320. So remember, we want to solve for B. So let's subtract 12J. So you have 4B equals negative 12J plus 1320. Divide everything by 4. And you get B equals and negative 3J plus 3.3. Okay, now take this equation and take this equation and put them into Y1 and Y2. And when you do that, just so this is like Y1 and this is Y2. Put them in, hit graph, and then you're going to do second trace 5, enter, enter, enter. And when you do that, you find out that your solution, I'm going to put that right here, is 0.25 and 2.55. Now remember, B is like the Y, so this is the B, that's brushes, and J is like the X, so the jars of paint are 25 cents and the brushes are $2.55. How much would you expect to pay for a deluxe set containing 7 brushes and 20 jars of paint? Okay, well, okay, so for our deluxe kit, this part C, we want to get 7 brushes and 20 jars of paint. So you're going to do 7 times what the brushes cost, and the brushes cost $2.55, plus 20 jars of paint, which cost 25 cents. And let's just see what those add up to. You get $17.85. You can use your calculator to figure that out. And if you have 20 jars of paint at 25 cents each, that's $5. And you add those two together. So the deluxe kit costs $22.85. Okay, now I told you this was going to be a long lesson. This was kind of a nasty problem. But I just kind of want to remind you that you're going to have to just dig in and hang in there with this. Do your homework, practice it, and see if you can figure it out. Come in and get some help. I'll help you if you're having trouble. Okay? Before school, after school, SOS, come, I'll help you. Okay?